Today we want to start looking at the trigonometric functions, and we're going to introduce them using triangles. In particular, we're going to look at right triangles. So a right triangle is a triangle in which one of the angles is a right angle. If we don't have a right angle in a triangle, then we call it an oblique triangle. So if you remember formulas for things like the area of a triangle, the height is always from one corner perpendicular to another corner. So I've drawn this triangle, so there's a right angle from the height. If I drop a right angle from this vertex down to the opposing side, that'll tell me the height of the triangle. So let's talk about what we know about triangles. In general, we know that the angles in a triangle are supplementary. The angles in a triangle So that means the angles in a triangle always add up to 180 degrees. So the sum of the angles is 180 degrees. So this is no matter what the triangle is, the sum of the angles has to be 180 degrees. So this makes sense when we talk about a right triangle. We know that one of the angles is a right angle. None of the other angles get to be right angles because I have to have enough sufficient number of degrees for all three angles. I can't take up two angles with 90-degree angles. That would leave me with 0 for the third angle. So there's the first thing that we want to remember about triangles. Today, we're going to specifically look at right triangles. Right triangles have one of the angles is a right angle. And in particular, we want to establish a relationship between the sides of a triangle and the angles in a triangle. We need something well, let's just state what we need. We need trigonometric functions to establish a relationship between the angles of a triangle and the sides of the triangle. We're going to define some trigonometric functions to establish a relationship between the angles and the sides of a triangle. So we want to be able to understand how all the sides and the angles are related. We're going to need trigonometric functions to connect the angles and the sides. We know that the angles in any triangle are supplementary. That's something that we always have. That's a relationship between just the angles. In a right triangle, we have a relationship between just the sides. In a right triangle, if I draw a right triangle, so if I label if I have a right triangle, we already have a relationship between the sides. We have a relationship between the angles. The sum of the angles is 180 degrees. And we also have in a right triangle a relationship between the sides. What's a relationship between the sides in a right triangle? So for just the sides in a right triangle, if I call the two legs A and B, and I call the side opposite the right angle C, what's a relationship between these sides? That would be 45, 45, 90 would be one particular. And it's not that A and B will equal C. A squared plus B squared equals C squared. If we call the two legs A and B, and C is the side opposite the right angle, then we can write the Pythagorean theorem as a relationship between just the sides. So A squared plus B squared equals C squared. What's the word for C? What do we call the side opposite the right angle? We have a word for it. The hypotenuse. Awesome. So usually when someone asks you what the Pythagorean theorem is, in the 21st century, we'll just say A squared plus B squared equals C squared, because we've been through algebra and formulas are how we normally communicate math. We just think of math as this big collection of formulas, which is a very terrible habit that we've developed over, pretty much decades. But the Pythagorean theorem, if we want to use words, we'd say the sum of the squares, the sum plus sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So if you want to say the Pythagorean theorem and you don't want to use algebra to do it, then you'll have to say the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. And then if we really want to be pedantic, you should probably say lengths of the legs of the right triangle is equal to the square of the length of the hypotenuse. But that would be like, that's even pedantic for me. So the Pythagorean theorem in a right triangle gives you a relationship between the sides of the triangle. So we've got a relationship between just the angles. We've got a relationship between just the sides. We need to connect the two. We got just the supplementary business. That's just the angles. And the Pythagorean theorem is just the sides. So I need something that combines angles and sides. Or we need something that connects angles and sides. All right, so let's do that. Any questions before we start making connections between the angles and the sides? All right. So we need to have some more terminology. This is a math class, and you should get used to lots and lots of terminology. Terminology all day, every day. So I was just writing the normal notes. I wasn't trying to hide anything from you by writing it way up here. So let's suppose that we have a triangle, a right triangle. Let's suppose we have a right triangle and we've got sides where A is one leg, B is the other leg, and C will be the hypotenuse. What we want to do is come up with names for the angles. So I'm going to label this angle in here, up at the top. This angle is opposite side A. So this angle is opposite side A. Because if we're standing in that angle with a hand on each of the legs that make up that angle, that's the side that we will be looking at. So that's what we mean when we talk about an angle or a side opposite a side or an angle. So I'm going to give this angle a name that's related to the side A because they're opposite each other. I usually call that alpha. So I'm going to say angle alpha is opposite side A. We could also say that side A is opposite angle alpha. So opposite side B, we're going to write the angle beta. So angle beta is opposite side B. So A and alpha are opposite, B and beta are opposite. So B is opposite beta. So we've named the angles opposite some sides. C is the hypotenuse, and the hypotenuse is always opposite the right angle, so the hypotenuse is always the hypotenuse. It lets the other sides and the other angles sort themselves out. C is the hypotenuse, no worries there. So we do want to reference angle side A as it relates to angle beta. So side A is opposite alpha and adjacent to beta, because side A is part of angle beta. Side A and the hypotenuse make up angle beta. So similarly, side B is adjacent to alpha. So we'll say that side B is adjacent to alpha. And side A is adjacent to beta. So in a right triangle, we always have a hypotenuse. We'll have an angle and a side opposite that angle and a side adjacent to that angle. So in a triangle, once we define which angle we're talking about, we can talk about an opposite and an adjacent and a hypotenuse. Any questions? So this is just the terminology, and the terminology that we're learning here is what we mean when we say opposite and adjacent. All right, now let's define the trigonometric functions. We want to define the trig functions in terms of opposite, adjacent, and hypotenuse. So we have one angle that we're going to be focusing on, And we're going to name the opposite and adjacent sides along with the hypotenuse. So in a right triangle, so the hypotenuse is always the hypotenuse. No choices there. That's the hypotenuse. It's the other sides that we're concerned with. So if I talk about this angle down here, and I'm going to give it the name theta, then this vertical side is the side opposite theta. And this horizontal side will be the adjacent side. I can just say opposite and adjacent because we're only talking about this one angle, theta. So opposite and adjacent have meaning. If I've defined theta and if I name the other angle, I would have to say specifically this is opposite theta and the horizontal leg is adjacent to theta. In terms of theta, we can define our three main trigonometric functions, the three trig functions. The three main trig functions. There are lots and lots of trig functions. These are the three big ones. The sine, which will denote sine of theta. The cosine, which we'll write cos and then theta in parentheses, and the tangent, which we'll abbreviate tangent theta. So we have sine theta, cosine theta, tangent theta. That's how we would pronounce these three symbols: sine theta, cosine theta, tangent theta. You might hear some other professors be like, all sin theta, or they would never say that. They would say sine. But they might be like, all cos theta. Do not do that. I don't care if some professor does that. You always say cosine. Or like tan theta. That's terrible. Don't just read the things in front of you. And if there's some professor watching this and they're like, all tan theta, yeah, fight me. That's fine. So tangent of theta. Say tangent of theta. Say the whole thing. Don't be lazy. That's just a pet peeve, so don't worry about that. So we're going to define the sine. This is a trig function that's being applied to an angle, and it's going to be a ratio of 2 of the sides. That's how we're going to define these in terms of theta. So let's do that. So the sine of theta is the ratio of the side opposite theta to the hypotenuse. Opposite to hypotenuse. The cosine of theta is the ratio of the side adjacent to theta to the hypotenuse. And the tangent of theta is the ratio of the side opposite to the adjacent. So we often say sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. These three things we just have to remember forever. You have until now to remember this forever. There are mnemonic devices to help you remember which one is which. My favorite mnemonic device for remembering which one is which is to say, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. I know that's just me saying the thing that I want to remember, but that's just how I remember it. So let's take a look at an example using an actual triangle. So let me build a right triangle. And let's suppose that this is this side is a 3, this side is a 4, and this is the angle theta that I want to use. All right. I've only given you 2 sides of this right triangle. What can we use to find the third side? So to find the third side, we can use the Pythagorean Theorem. Also, the 2 legs, this is a right triangle, is a 3 and a 4, so we know that the hypotenuse is a 5. Now, that would be the most efficient way, just knowing things. But let's pretend that we didn't recognize this right away. To find the hypotenuse, I would say the sum of the squares of the legs of the right triangle is equal to the square of the hypotenuse. So I'll call it C like I normally do. So C squared is 3 squared, which is 9, 4 squared, which is 16. So C squared is 25, and so C is equal to 5. So this is a 3, 4, 5 triangle. I had 2 of the sides, and it's a right triangle. The Pythagorean theorem gives us a relationship between the sides of a right triangle. So now that we've got the hypotenuse, we've got 4 pieces of information about this triangle. We have an abundance of information now. So now we're looking at a 3, 4, 5 triangle. And I think I labeled the one on the angle on the bottom, yep, as theta. So now that we have the 3 sides, 3, 4, and a hypotenuse of 5, we can write down the sine of theta. So the 3 is opposite to theta. The 4 is adjacent to theta. So I can write down sine of theta is opposite over hypotenuse. Sine is opposite over hypotenuse. So now we know that the sine of theta is 3/5. So with these 3 sides, 3, 4, and 5, and theta is opposite to 3, what is the cosine of theta? I spelled cosine wrong. What is cosine of theta in this case? 4/5. We take the side adjacent to theta, 4, and divide by the hypotenuse, 5. And the third of the big 3 is the tangent of theta. Oops, I should put parentheses. What is the tangent of theta? Tangent is 3/4. Tangent of theta is 3/4. Opposite over adjacent. Opposite 3 over adjacent 4. So the ratios of the sides will give us a trig function of the angle. Any questions? Note that we didn't get the angle itself. We just have the sine of theta or the cosine of theta or the tangent of theta. So that's an important thing to note. It's like, oh, well, how does this help us figure out what the angle is? So we didn't get, the ratios aren't the angle. The ratios are the value of the trig function of the angle. Ratios aren't the angle. Ratios are the trig function of the angle. We have to undo the trig function to figure out what the angle is. I'm going to put that in quotes because that's not a technical phrase for what we're doing. We need to undo the trig function to find the angle. We need to undo the trig function to find the angle. So the sine of theta is 3/5. I got to figure out what angle theta would have a sine of 3/5. So the sine of what angle is 3/5? To do that, we're going to need a calculating machine. And we're trying to undo the sine function. And to undo a function, we use the inverse function. So to undo the trig function, we are going to use the inverse trig function to undo the trig function. So to undo a function, we use an inverse. So the sine of theta is 3/5. I got to figure out what that angle is. I don't know this one right off the bat, off the top of my head, so I'm going to use my calculator to do it. That's why we have the thing. So first I'm going to go into the mode and say, I want you to measure angles in degrees. So notice in the menu, I don't want radians. I don't want it highlighted that way. I want to say, tell me degrees. So there we're going to do degrees. And I want to do an inverse. So if the sine of theta is 3/5, then theta is the sine inverse of 3/5. So I want to make sure my calculator is in degrees. And I want to do a sine inverse. Now on my calculator, here's the sine button. And above that is the sine inverse button. And it's written in blue. So I don't know if it'll focus on that. There's the sine inverse button. The camera's saying, hold still. And I'm like, oh, I can't. I have had too much coffee or not enough coffee. So I'm going to do the sine inverse. So it's in blue, so I have to press the second function. Sine inverse of 3/5. So the angle is 36 point, let's round it off to 9 degrees. The other word for the inverse trig function is the arc sine. But that's too much to type apparently, so they just put sine to the -1 as a sine inverse. We should also, so the cosine of theta is 4/5. So if we do a cosine inverse of 4/5, we should get the same angle. So that's good that that happened. And if we do a tangent inverse of 3/4, we get the same angle. We had 3 ways to find that angle. It's a good thing they all delivered the same value. Otherwise, one of them would be wrong. Any questions?
How does it work again? I'm like trying to use the calculator also.
So to get to the calculator, you have to, first of all, you have to go into your mode and make sure you are in degree mode. Otherwise, it's going to give the answer in radians. We haven't talked about that yet. So make sure it's in degrees. Then get out of your mode. And then to get at the blue functions, press the blue second button. So second sine inverse, and then 3/5, 3 divided by 5.
Okay. So mode degree. Okay, thank you.
Any questions? So if you read the table of contents, you're like, oh, hey, man, it's not till a later chapter that we have to use inverse trig functions. We get to learn about inverse trig functions. And I'm like, oh, incorrect. We just did. We didn't learn all the details that we're going to want about inverse trig functions, but we've got to be able to use them to find angles. That's how we're looking for a connection between the sides of a triangle and the angles of a triangle. So let's look at another example. Let's suppose that I have a right triangle. And let's suppose this angle is it looks less than that. So let's call this a 27-degree angle. And let's suppose that the hypotenuse of this right triangle is 7. And let's suppose that we want to know what's the side opposite. So I usually put A, and so let's call this B. Let's suppose that I want to find the side opposite the 27-degree angle. So what I have is I have an angle. I have B, which is the side opposite the 27, and 7, which is the hypotenuse. So B is opposite the 27. So the side that I'm looking for is opposite the 27, and I also have the hypotenuse. So what trig function am I going to use that involves the opposite and hypotenuse? Sine. Cool. The trig function that relates opposite and hypotenuse is sine. So I'm just going to write what I know about the sine of this 27. So the sine of 27 is the ratio of the side opposite the 27, which I called B, to the hypotenuse, which is in this case 7. Now I just want to figure out what B is equal to. Since the sine of 27 is B divided by 7, that means the side B is 7 times the sine of 27. So this tells us if I solve this equation for B, we see that B is equal to 7 times a sine of 27 degrees. And that tells me exactly what I need to push into the calculator. So I want to figure out what 7 times the sine of 27 degrees is. So 7 sine 27 is 3.18, we'll call it. Any questions?
So I guess maybe I'm not understanding it correctly for the last problem that we were working on.
Uh-huh.
But how come this, the inverse sine, inverse cosine, why were those all equal to the same number? Wouldn't they be different because you're using different fractions?
No, because we're not just using different fractions, we're also using different trig functions.
And they just all equal the same. Oh, okay, okay.
They're all trig functions relating the same angle to those three sides.
I
So,
understand.
so the idea is just use whatever is available. We had an abundance of information. That's why I wrote down all three.
Okay, but it should be okay.
So, and I just wanted to reinforce that using the three different trig functions, since we had all three of the sides, they should all tell us the same angle.
I understand. I understand.
So in a 3, 4, 5 right triangle, the angle opposite the side 3 will always be 36.9 degrees. And since I wrote all three of them down, you can tell that even if we've already killed the big boss, we're in a dungeon. If there's rooms that we skipped, I'm going to want to go back to those rooms. It's like, oh, well, what's in those rooms?
The
And
same
then the
thing.
rest of my
I
party
get
be
you.
like, oh, the rest of my party be like, oh, but we've already done the big boss. We can go back and get our quest reward. I'm like, oh, no, we have to finish everything. So anyway, what are we talking about? Not D&D, sides and angles. The important thing is that we're looking for a relationship between the sides and the angles. And the game that we're going to play is I'm going to give you 3 pieces of information about a triangle, and you're going to have to tell me the other 3. That's called solving triangles. And we spend a lot of time getting used to our trig functions by solving triangles. Any other questions? So yes, I have been a DM. In fact, I'm a dungeon master now for 2 games, because the one I was a player in is on hiatus. All right. That's going to be it for today. Get started on the homework that's in chapter 1. Read the section, get started on the homework, or you could do the standard student thing and just start on the homework and then be like, oh, why don't I understand this? And then I'll be like, oh, did you read the section? And you'll be like, oh, no, why would I do that? It's like, oh, go read the section. It's like, oh, no, I'm just going to have you explain it to me. And then I'll be like, oh, no. And then there'll be a pause. Then I'll be like, oh, fine. And then I'll explain it. All right, that's going to be it for today. I will see y'all on Wednesday. Get started on your homework and watch out. A quiz might show up between now and then. That's it for today. Thanks for playing.